All right, Precalc, we are working with our calculator today, and there are two buttons on your calculator. Next to the button 7, there is a log button, and next to the button 4, there is a ln. So log, here we go, is any time you have a log base 10. So literally, they're telling us to evaluate the function and round 4 decimal places. They're asking us to find log base 10 of 100. And in my calculator, I can literally just hit the log button, the 10, and then the enter button. And what do I get? I do get 2, because 10 to the second power is 100. So we're going to do the same thing for these. This is just saying log base 10 of 1/5. This is saying log base 10 of 3.25. And this is saying log base 10 of -4. Push pause if you haven't done it. And I'm going to go over the answers. So when I do log base 10 of 1/5, I get negative 0.6990. When I do log base 10 of 3.25, I get 0.5119. And notice this one is saying 10 to what power is -4. You're going to see an error on your calculator, which means that it cannot happen because it says it may be a complex number, or can anything to a power be a negative. So in this case, there is no solution. One thing that I really want to strongly remind you of is that logarithms, this doesn't even say logarithms, I can't say it or spell it, logarithms are exponents. And we forget that a lot. Remember, it's super easy because they're exponents, and we want to make sure that we're just looking at them as exponents. So we should already know what one of these graphs looks like. Graph of f of x equals 4 to the x. Remember that this is going to go at 0, it's going to go through 1. At 1, it's going to go through 4. And remember, this is going to never, ever touch the x-axis because it can't be negative. So my question to you is, what does the graph of g of x look like? If this is f of x, what does the graph of g of x look like? So in your calculator, at the y sub 1, remember we're going to hit math, and we're going to scroll up to a log base, and we're going to put in log base 4 of x. And when I graph this, you're going to see some interesting things. Do you see what I see? Notice that this is a reflection over the line y equals x. So this line y equals x is just a reflection of the exponent to the logarithm. So the red one is the g of x, the logarithm, and the blue one is the f of x, the exponent. Transformations we should already be familiar with, so I'm just going to talk about this quickly in example 6. Log base 10 of x minus 1, they're just telling us to describe. So what's happening from log base 10 of x? Log base 10 of x is going to look like this. Remember, it's going to go through 1, and it's going to go all the way up to 10. It's going to look like this. But what happens when I have minus 1? Where is that going to go? It's going to go down 1. So it's going to be almost the same graph, but it's going to go down 1, so it's going to look a little different. What about on B? If I have x plus 2 inside of parentheses, is that going to go up, down, left, or right? So the first graph we know, log base 10 of x, is going to go here, and it's going to look like this. But now when I have the new graph, log base 10 of x minus 2, that is going to go down to the left too. It kind of looks down to me, but it's just going down too. and it's going to look like that. Great job. All right, moving on to some natural logarithms. We talked about this. Remember, for x is greater than 0, y is equal to the ln, the natural logarithm of x, if and only if, that IFF means if and only if, x is equal to e to the y. Remember, this is just an exponent, and e is a number, and that number is approximately 2.718 something. The function given by f of x equals log base e of x is equal to the logarithm. So we don't really have to write this out because we know that the natural logarithm is what it's going to be seen as. So the first one says just to use a calculator to evaluate, and they're actually giving you ln of x plus 1. Remember, on your calculator, on your TI-84, that is next to the number 4. So you're going to see a button that says LN. So push pause and put all these in, and I'm going to put in the answers as well. All right, so when I put in for x 73.25, they are asking us to round 4 decimal places, so this answer will be 5.2939. When I put in for x 0.4, I get 0.0837. What about when I put in -2? So this is saying ln of x, which is log base e of x, and they're asking us when that equals -2. Notice you will get an error. There is no solution here. It's not possible. And when I put in 2 plus √3, we get 2.3170. Properties of natural logarithms are very, very, very similar to the other properties that we did of logarithms. Notice ln of 1 is equal to 0 because anything to the 0 power is equal to 1. And to do a highlighter. So ln of 1 is equal to 0. The next one, the ln of e, the natural logarithm of e, is equal to 1 because e to the first power is equal to e. All right, the next one that we're going to look at, ln of e to the x power is equal to x, and e to the ln of x. So this is going to be a lifeline. Anytime you see an e, you want a ln, and when you see a ln, you want an e. All right, and the last one that we see, it says if the ln of x is equal to the ln of y, then x equals y. So let's go ahead and dig in and do some of these questions. The first one, anytime I see ln and e together, notice, anytime I see ln and e together, that's equal to 1. So one of the properties tells us that anytime you have an exponent, you're going to fly it to the front. So this is literally saying 1/3 times 1. What's that equal to? That's equal to 1/3. Now, you'll get used to just canceling that out. You can also put it in a calculator, and you'll be fine. Now, what happens with e to the ln? So e to the ln of x, if you look over here in the yellow on the top right, it says e to the ln of x is equal to x. So again, this is just equal to 1. So this is just saying 8 times 1, and that is equal to 8. All right, moving on. We have a tendency to forget these, so please don't forget these. This one's saying 15 times the ln of 1. That is a number 1. Well, we know ln of 1 is equal to 0, so this is saying 15 times 0, and that's equal to 0. And again, that property is up here on number 1 in orange. The ln of 1 is equal to 0. All right, the last one is saying ln of e over 6. Well, remember, anytime I have ln of e together, that is equal to 1. So this is just saying ln of e times 1 over 6. Well, that's 1. 1 times 1/6 is equal to 1/6.